What's up, party people? Give me a second. Audio. All right, so let's go here. All right, so what's going on? Today we're going to talk about Unit 5, Lesson 5. Now, if this video looks crooked, this is my first time streaming live from my iPad. So if this video is turned sideways, then I apologize. Or if it looked like I'm looking to the side, don't worry. I'm going to make this as simple as possible, but I want y'all to be able to see the lesson in person. So let me share my screen. Let's see, let's go here. Start broadcast. All right, so I'm going to share my screen. And hopefully y'all can see this. All right, so hopefully, let me look on YouTube real quick. Give me a second. Let me see. I need to know. Let's see. If I can see it, it'll tell me. Can't see it on live. I don't know. We're gonna make it do what it do. Well, actually, you know what? I can check it over here. Okay, so what's up, party people? Give me a second. Audio. All right. Well, we're gonna see what happens, and so hopefully y'all can see this. If you can't, I'm gonna be really upset, but whatever. So yeah, let's get into it, right? So we have the bridge. We're gonna do this piece by piece, and the bridge is, why is it not letting me write on this? I need to just a minute. Hold up. Let's try to do something different. So I'm sharing my screen. All right, let's stop sharing my screen. So stop sharing. Okay, why is it not live anymore? Okay, it is live, but I need y'all to see what I'm sharing on my screen. So give me a second. All right, we're gonna make it do what it do. Y'all give me a second. This is when technology becomes a friend sometimes, and sometimes you gotta work with it, but we're gonna make it happen. Cool. I think I got it. Let's see. Let's go back to Zoom. All right, cool. So, all right, let's try this now. Share content. Here we go. All right, here we go. So y'all should be able to see this now. Boom. All right, so this is bridge number 1. Now you're gonna have to work on, copy this in your workbook. So this is, with this bridge, you're basically just following what we call a function rule. Okay, so you have a function rule, which is this in the middle, right? So the input is this row of numbers up top. Okay, so that's your input. All right, so if we start with 0, if I input 0 here, and then I take the number 0 and I divide it by 4, and then after I divide it by 4, so 0 divided by 4 is 0, and then if I add 2 to that, 0 plus 2 is 2. So my output is 2, okay? Let's erase that. Our next input is gonna actually be 2. So 2 divided by 4 is 1/2 or 0.5. And then if I take 0.5 and add 2, I get 2.5. So now I have 2.5, okay? We're gonna do the same thing. We're gonna say, next, we're gonna take number 4, and that's gonna be our input, okay? So the number 4 divided by 4 is 1, and 1 plus 2 is gonna give me 3 as my output, all right? Do the same thing again with the number 6. If I take 6 divided by 4 as a decimal, as a fraction, is 3/2, but as a fraction, it's 1.5, right? And so 1.5 plus 2 gives me 3. Let's write it up here. 3.5, okay? In this case, decimals are totally fine. You might hear me say the fraction version, but the decimals are cool too, all right? If we do the same thing, let's say we have 8, okay? So 8 divided by 4 is 2, and then 2 plus 2 is, let's put it up here first, 4, okay? So that's 4 right there. We're gonna do the last one. We're gonna put our input as 10. 10 divided by 4 as a fraction is 5/4, but as a decimal, it's 2.5, right? Yeah, 2.5. I'm sorry, I said 5/4, but it should be 5/2, which is 2.5. And 2.5 plus 2 gives me 4.5. Okay, so you can see our inputs in the table. We do something to those, which is this, what we see here. This is going to be a function rule. It's going to be an equation, okay? Things like that. So when I take my input and put it into the equation and I do the calculations, it's going to give me a certain output, all right? So that's the bridge 1. Let's clear this out. And we're going to go on to the next one, bridge 2, right? So bridge 2, as you can see, it says consider the equation Q equals 4 plus 0.8 times P. Explain or show your reasoning. What value of Q would make the equation true when P is 7? So we're going to really rewrite this equation, and we're just going to change P to 7. So we're going to say Q equals 4 plus 0.8 P. And then now they give us P, right? So let's change that P to, instead of putting P there, I want to put 7, because that's the value that they give us. Now that's a little sloppy, but it's okay. All right. So then now I'm going to do the calculations, right? So what we have is, if we do the calculations here, Q is equal to 4 plus 0.8 times 7 is 5.6. And then Q equals 4 plus 5.6 is 9.6. Okay. So what this is saying is, when P is equal to 7, Q is going to equal to 9.6. All right. Let's see. All right, so we'll do the same thing here. We'll say when P is equal to 100, what is the value of Q? Okay, so Q, that's not Q. Okay, so Q is equal to 4 plus 0.8 times 100. Okay, remember, order of operations, we need to multiply before we add. So here, Q is equal to 4 plus 80. All right, which now if we just add those, Q is equal to 84. All right. Same thing. Well, the difference with this next one is now it says what value of P would make the equation true when Q is equal to something. So here they give us Q first. So we're going to rewrite the equation, but since Q is equal to 12, we're going to change that. We're writing the same equation that they gave us in the beginning. And we're going to say 4 plus, let's make that neater. 4 plus 0.8 times P. Okay. So then now we have to solve for P. We're doing this. You all have been doing this for a long time. So we're just solving the equation for P. All right. So the first thing I want to do is I want to subtract the 4 from both sides. 12 minus 4 is 8. And then 8 equals, that's canceled, 0.8 P. And if I want to solve for P, I divide both sides by 0.8. So boom, 0.8 there, 0.8 there. And 8 divided by 0.8 is actually 10. So 10 equals P. Okay. So basically, if we use this sentence at the bottom, I found the value of Q to be blank, which makes the equation true because blank. So for example, if I change this because we're talking about P, I can say I found the value of P to be 10, which makes the equation true because when I subtract 4 from both sides, and then I divide both sides by 0.8, I get 10 equals P. All right, let's do another example like that. Let's look at this one. Once again, it says Q is 60. So we're going to write the original equation, but instead we're going to change Q to 60. And then we're going to say 4 plus 0.8 times P. And then we're going to solve for P. All right. So here we subtract 4 from both sides. So 60 minus 4 is 56. These cancel. So 56 equals 0.8 times P. And then if I divide both sides by 0.8 once again, then I actually get that, let's see, 56 divided by 0.8 should be 70. Okay, so these cancel, and then 70 equals P. Notice in parts A and B, you did the same thing. You multiplied first, and then you added 4 to it. In number 2, in parts A and B, you did the same thing. You subtracted the 4 first from both sides, and then you divided by the 0.8. So actually, the difference between number 1 and number 2 is the steps in the process are just inverse steps. Okay, that is your bridge 1 and 2. All right, so let's clear this and let's go on to the activity. All right, now this is where it's going to get, you got to really pay attention and lock in, because when you get here, what we need to do is we need to see how these situations connect. So it says a machine in a laboratory is set to steadily increase the temperature inside the machine. The temperature, this is very important, the temperature, see what I highlighted in my notes. Okay, so the temperature in degrees Celsius after being turned on, or you can highlight this whole thing, is a function of time in seconds. Okay, and they give you the equation. So the temperature is your input. Your output. So temperature is output. Let's do it like this. Let's say output, and your time is input. Okay, so temperature output, time input, right? So now it says, what does f of 3 mean? And I'm going to just type these out. So f of 3 is basically, let's see if I can get let me type. Text. All right, for some reason it's not showing my text. Let's try something. All right, we got to improvise since it's not Let's see, boom, boom. All right, so this is basically the all right, this is the temperature of the machine 3 seconds after it's turned on. Okay, so the temperature of the machine 3 seconds after it's turned on. We use seconds because it told us the time in seconds. All right, number 2 says find the value of f of 3 and interpret that value. So now we're going to take this equation and we're going to say f of 3 is going to be 22 plus 1.3 times 3 because they told us f of 3. So we're replacing this t 3 seconds. All right, so now let's do the math. We're going to multiply 1.3 times 3 first. So 22 plus 3.9. Okay. So then f of 3 is going to equal to 22 plus 3.9 is 25.9. So we interpret this as the machine is 25.9 degrees Celsius 3 seconds after it's turned on. Once again, the machine is f of 3 equals 25.9. That means that the machine is 25.9 degrees Celsius after, 3 minutes after it's turned on. One more time. The machine has a temperature of 25.9 degrees Celsius 3 minutes after it's turned on. Make sure you're writing these. And this is actually going as a grade in your workbook. So make sure you get this done. All right. So now, next, it says a machine in a laboratory is actually, you know what? Hold on. Wait. Okay, so it's the same scenario. So I won't really read it to you. So we've got the same scenario, same equation, but number 3 says, where did I put my pen? It says, what does the equation f of t mean in this situation? So this is going to be I don't know why the text isn't working, but that's okay. So this means so we still have temperature. So the temperature in degrees Celsius inside the machine after being turned on is a function of time in seconds. Okay, so temperature is a function of time. So this is the temperature. Let's just say it like this. Let's say this represents because we're talking about seconds, the number of seconds it takes the machine to reach 35 degrees Celsius. Why? Because they give us just T. They don't tell us how many seconds. So we don't know how many seconds, but we know that however many seconds it is, when I put it into this equation here, whatever I calculated gave me 35. I just don't know what value of T that is that gave me 35. Well, in the next problem, number 4, we're going to find out what value of T gave us 35. So if it says f of T equals 35, we're going to rewrite the equation. So we're going to say 35 because it said f of T equals 35. So we can substitute this 35 and it equals 22 plus 1.3 times T. Now we just solve for T. Well, the first thing you need to do is subtract 22 from both sides. Okay. 35 minus 22 is 13. 22 minus 22 is 0. So we bring down our 1.3 T. And then now to solve for T, we divide by 1.3 on both sides. And then that gives us 10 equals T. Okay, well, what does this mean, Mr. Harris? Well, 10 seconds after the machine turned on, it's going to have a temperature of 35 degrees Celsius. Okay. So that's that. Let's clear this out. Let's go on to another one. We're rocking and rolling. I think we missed one. Is it number 5? Let's see if I can find that slide. Boom, boom, boom. Oh, I might have missed it. Okay, so I'm gonna turn on my whiteboard. I'm gonna stop sharing this right now, and I'm gonna share the whiteboard because um actually let's do it like this. Let's share my screen. And hopefully I have it. Hopefully I have it here. Number 5, right? So number 5 says write an equation involving f. Let's do it like this. Let's solve it. And that way I can stop sharing my screen. Stop broadcasting. Boom. So let's go back here, Zoom, and share content, photos. Boom. So boom. Add. All right, so now number 5, it says a machine in a laboratory. Same scenario. I'm not going to read that again to you. But number 5 says write an equation involving F that represents each of those situations. The temperature in the machine 30 seconds after it's turned on. Okay, so 30 seconds after the machine is turned on is basically F of 30. Okay, so F of 30 is equal to, same equation, boom, 22 plus 1.3 times 30. That's it. The time when the temperature inside the machine is 100 degrees Celsius. So this one is a little different. We could say simply, we don't know how much time it's going to take it to equal 100 degrees Celsius. So we can just simply say f of t equals 100. Okay. So that's activity 1, all 5 problems. Make sure you write these down. They're going to be for a grade. Let's clear this out and let's go on to activity 2. Stop share content again, and we're gonna say activity 2. All right, add. Now, activity 2, the first part asks us a bunch of different things, right? So it says the function W gives the temperature in degrees Fahrenheit of a pot of water on a stove T minutes after the stove is turned on. So we have to interpret these, right? So notice it says take turns with your partner to explain the meaning of each statement in this situation. Okay, so let's explain what this means. All right, so number 2, this is basically it's finally wanting to type. Okay, number 2. So letter A is the water is 72 degrees Fahrenheit. I'm gonna say I probably spelled that wrong. Yeah. Boom. Uh, okay. So that's A. All right. So A. For B, let's put this up here. So A. Boom. So then B, let's make this a little smaller. So B, basically what this means, it says W of 5 is greater than W of 2. So basically is what it's saying is, remember the input 5 on the left side is saying this is the temperature 5 minutes after it's turned on, right? So this represents the temperature the temperature 5 minutes, or the temperature after 5 minutes, it has the greater than symbol between them, is higher or warmer than the temperature after 2 minutes. Okay, let's look at C. C says W of 10 equals 212. So the temperature after 10 minutes is 212 degrees Fahrenheit. Okay. And the cool thing about this is that when you look at this, 212 degrees is when water boils. So basically, this is also saying it took 10 minutes for the water to boil. Okay. Let's look at D. All right. The temperature. So basically, this is saying the temperature after 12 minutes is the same as the temperature after 10 minutes. Okay. Let's do this. Let's get some space so y'all can see this. E basically says, so W of 15 is greater than W of 30. So this is saying the temperature after 15 minutes is hotter. Excuse me, you can say higher, warmer, either one, than the temperature why is it not spelling right now? Temperature after 30 minutes. Okay, so basically what that says, and you can translate these in your own words. It doesn't have to be written exactly like I'm saying it, but you got to understand in this scenario, W of 15. So after 15 minutes, the water was hotter than it was after 30 minutes. Okay, and then now let's look at F. F, you got to be really careful because F is a tough one, right? So F is saying, it says W of 30 minus W of 20 equals negative 75. Now, remember, the number in parentheses, this, let's look at this. This first one, this is the temperature of the water after 30 minutes. This is the temperature of the water after 20 minutes. Now, we know 20 comes before 30, right? And then it says it's equal to negative 75. Well, what's happening is what this is saying is 30 minutes after the stove was turned on, compared to 20 minutes after the stove was turned on, the temperature decreased by 70 degrees. So what we can say is let's go text. Don't tell me the text don't want to work again. All right. Let's see. All right, so it's not working on me again. I don't know why. So this is basically saying the temperature. Oh, there we go. Okay, so for F, the temperature decreased by 75 degrees Fahrenheit between 20 and 30 minutes. Okay, you got to look at this one again. Okay, so basically what it's saying is if we take the temperature at 30 minutes, subtract the temperature at 20 minutes, it's going to be negative 75. But a way to say that really in just day-to-day language is the temperature decreased by 75 degrees between the 20-minute mark and the 30-minute mark. Okay, so look at that one again if you have some trouble with that one. Now, that is activity 2, part 1, okay? Let's look at activity 2, part 2. If I can get this, let's see, boom, let's take this back. All right, we are done. Oh, no wonder, that's why I was doing that, okay? So now let's look at activity 2, part 2. Let's clear this first. And this video is super long because I wanted it to really be one video instead of making a bunch of clips, right? So I'll mark up the timestamps and things like that later. So now it says, if the statements in the previous question represent the situation, sketch a possible graph of the function. Now, what you're going to see me sketch, yours may not look exactly like this if you've drawn this graph before watching this video, okay? But we're going to take information. So we're going to say, it says, so when we look at the different temperatures, so we're basically using the temperatures in part 1, A, B, C, D, E, F, and we're going to use those different points. Remember, there's input, there's output. So for part A, we said that the water is 72 degrees before the stove is turned on. So when we look at this, we're going to say, let's say this is 25, 50, 75. So about right there, okay, when the stove is turned on. Part 2 says the temperature after 5 minutes is greater than the temperature after 2 minutes. So let's just say randomly after 2 minutes, we chose the temp to be right there. We don't know what it is. We just know the temperature after 2 minutes is less than what the temperature is after 5 minutes. Okay, so then after 5 minutes, we're going to make the temperature higher. Then it says the temperature after 10 minutes is 212 degrees. So boom, this is 225. So 212 would be about right there. Okay. And then it says that the temperature after 12 minutes is the same temperature after 2 minutes. So let's put that about right here. Then it says the temperature after 15 minutes is greater than the temperature after 30 minutes. Now, for me, and you may or may not think about this, I was thinking, well, after it gets to 212 degrees, it's boiling. So it's not going to get any hotter. So I left it there. But then it says after 30 minutes, I'm sorry, I put that point at the wrong place. I'm sorry. Because it tells us about the temperature after 15 minutes. So we do 15 minutes here because it's 212 degrees. That's as hot as it's gonna get. So then after 20 minutes, it's hotter than it was after 30 minutes. So we're just gonna say it went down after 20 minutes and put it there. And then now, so this number is 175 degrees, right there. But now it says in F that the temperature decreased by 75 degrees between the 20-minute mark and the 30-minute mark. So if I have 175 minus 75, then it has to be right here at 100 after 30 minutes. So we can connect these points. Let's see if I can draw a line. We can connect these points right there. And then I can draw here. And then I can draw another line right there. All right. So that's basically what this graph would look like. Yours may have looked different from this before you watch this video, but I want you to think about these scenarios and these specific situations. Please make sure you copy these solutions into your workbook. And if you have any questions, talk to your partners about it. Make sure you tell your friends to do their work and things like that. Hopefully this is helpful to you all. You can skip through the video, pause it, rewind it. Remember, like, share, and subscribe to the videos on the channel. And hold up, I got to sign off. So hopefully this was helpful to y'all. Remember, stop, rewind it, or whatever you got to do to make sure you understand what we're talking about in these different scenarios, as if I was teaching this right in front of you. I actually might try this more often. But instead of separating the videos right now, I'm going to do them as one big video. Sometimes I may separate them. I don't know. That was a lot. I think this is pretty long. But for today, lesson 5, we're just gonna keep it as one video. So remember, I appreciate y'all. Be your best, stand on what you stand on, and